Now, I know what you're thinking. We've barely begun to fully understand our universe, lest we entertain the thought of multiple universes. Could the truth be found in the multiverse theory? Just 10 days before his death, legendary physicist Stephen Hawking published A Smooth Exit from Eternal Inflation. This paper was co-authored with Thomas Hertog and not only discussed the origins of the universe, but extensively explored his findings on the multiverse theory and argued the affirmative. So, Dr. Strange frolicking around multiple universes and coming across bizarrely different versions of himself might be more reality than it is comic book fiction. What is Stephen Hawking's multiverse theory? How does it affect us? And how has the James Webb Telescope proven this theory? The James Webb Telescope is designed to look into the distant past, searching the universe to find out what happened before the Big Bang, and giving us new insight into the origins of the universe. Everything we know about the universe has changed after years of searching. Let's establish some basic information. The universe is estimated to be 14 billion years old. It is widely believed that everything we see today was created by the Big Bang. Following the Big Bang, the universe continued to expand. Over time, the stars and galaxies formed. Our sun is one of the many billions of stars in our own Milky Way. As everyone knows, the sun is the center of the solar system, and the solar system revolves around the sun at an average distance of 93 million miles or 150 million kilometers. But this could just be one of the infinite universes out there. According to Stephen Hawking's theory from the 1960s, our universe is just one of many separated by an infinite expanse. For years, scientists have searched for evidence of other universes, and now they may have found it with the James Webb Telescope. The telescope has been able to view other universes using gravitational waves. Other universes are expanding faster than ours. This implies that we live in a bubble universe where there are multiple Big Bangs taking place, according to lead researcher Rangaram Chari from Texas A&M University. There are more than 100 different types of universes. We could be a part of this cosmic environment. Professor Stephen Hawking's final theory on the origin of the universe, which he worked on together with Professor Thomas Hertog from KU Leuven, was published in the Journal of High Energy Physics in 2018. The theory of the multiverse is closely tied to a theory submitted for publication before Hawking's death in 2018. This theory relies on string theory and suggests that the universe is finite and much simpler than current theories about the Big Bang suggests. Professor Hertog, who has been funded by the European Research Council, first talked about the new theory at a conference in the University of Cambridge in July 2017. This conference was held to celebrate Professor Hawking's 75th birthday. Some recent theories about the Big Bang propose that our local universe came into being with a quick burst of inflation immediately after the Big Bang itself, which basically means that the universe expanded rapidly immediately following the Big Bang. It is believed that there are regions where inflation never stops once it starts, and that quantum effects could keep inflation going forever in some regions of the universe. Therefore, globally, inflation is eternal. If inflation ended and stars and galaxies formed in a hospitable pocket universe, then the part of the universe we can see would be a hospitable pocket universe. Professor Hawking said in an interview from 2017, "The usual theory of eternal inflation predicts that globally our universe is like an infinite fractal, with a mosaic of different pocket universes separated by an inflating ocean. The laws of physics and chemistry can differ from one pocket universe to another, which together would form a multiverse." But I've never been a fan of the multiverse. If the scale of different universes in the multiverse is large or infinite, the theory can't be tested. According to the paper, this account of eternal inflation is not a theory of the Big Bang. Professor Hertog explains, "The problem with the usual accounts of eternal inflation is that it assumes an existing background universe that evolves according to Einstein's theory of general relativity and treats the quantum effects as small fluctuations around this. However, the dynamics of eternal inflation wipes out the separation between classical and quantum physics. As a consequence, Einstein's theory breaks down in eternal inflation." Professor Hawking adds to it saying, "We predict that our universe on the largest scales is reasonably smooth and globally finite. So, it's not a fractal structure." The theory of eternal inflation, which was developed by Professors Hawking and Hertog, is based on string theory, which tries to combine gravity, general relativity, and quantum physics by saying that the smallest parts of the universe are tiny strings that vibrate. The eternal inflation universe model is a hypothetical universe model that grew out of the Big Bang theory. Eternal inflation suggests that the inflationary phase of the universe's expansion lasts forever throughout most of the universe. Because the regions are expanding exponentially rapidly, the majority of the volume of the universe at any given time is expanding. Because eternal inflation produces a multiverse with an apparently infinite size, only a minimal fraction of it is inflated. Their approach considers the idea of holography from string theory, which suggests that the universe is a large and complex hologram. This implies that certain 3D spaces can be mathematically reduced to 2D projections on a surface. Hawking and Hertog used a variation of the concept of holography to project the time dimensions in eternal inflation. Holography is a technique that allows a wavefront to be recorded and later reconstructed. Holography is best known for creating three-dimensional images, but it is also used in many other ways. It is possible to make a hologram for any type of wave in principle. This allowed them to avoid the use of Einstein's theory when describing eternal inflation. The new theory suggests that eternal inflation is brought to a halt at the beginning of time. Professor Hertog further explains, "When we trace the evolution of our universe backwards in time, at some point we arrive at the threshold of eternal inflation where our familiar notion of time ceases to have any meaning." The earlier no-boundary theory of Hawking said that if you went back in time to the beginning of the universe would shrink and close off like a sphere. This new theory is different from their earlier work. Professor Hertog mentioned, "Now we're saying that there is a boundary in our past." They used their new theory to make more reliable predictions about the global structure of the universe and predicted that the universe that emerges from eternal inflation on the past boundary is finite and much simpler than the infinite fractal structure that the old theory of eternal inflation predicted. Their new theory allows for more reliable predictions about the global structure of the universe to be made, and it was predicted that the universe that emerged from eternal inflation on the past boundary was finite and much simpler than the infinite fractal structure that the old theory of eternal inflation predicted. If the results of their work are confirmed by further research, they would have profound implications for the multiverse hypothesis. Professor Hawking revealed, "We are not down to a single unique universe, but our findings imply a significant reduction of the multiverse to a much smaller range of possible universes. This makes the theory more accurate and able to be tested." Hertog will investigate the implications of the new theory on smaller scales which are attainable with our current space telescopes. He thinks that primordial waves, ripples in space-time which came out of eternal inflation, are the best chance so far to test the model. Since the beginning of our universe, these gravitational waves have undergone dramatic stretching, so they would now have extremely long wavelengths and would be outside the range of the current LIGO detectors. LIGO is an abbreviation for the Laser Interferometer Gravitational Wave Observatory, which is a large-scale physics experiment and observatory designed to detect cosmic gravitational waves and to develop gravitational wave observations as an astronomical tool. It is possible that the waves will be detected by the European Space-Based Gravitational Wave Observatory, LISA, or seen in future experiments measuring the cosmic microwave background. In more recent times, scientists have been able to begin searching for evidence of the existence of the multiverse theory. It is possible that the recent images of the James Webb Telescope aided in proving Stephen Hawking's theory correct. Scientists have discovered a strong signal from the infrared galaxy known as MAX 1149-JD1, a signal they believe may have come from a primordial gravitational wave. This would mean the signal originated from an event so long ago or at such a large distance that light has not yet reached us. This may be evidence of a universe that is similar to ours but is much older. Even though there are some people who don't think that there are an infinite number of universes out there, this one might be the first one we've found. Anthony Aguirre, a physicist at the University of California in Santa Cruz, thinks this could prove that there may be many pasts and futures of the world that exist at the same time. It would mean that all possibilities exist. There could be an endless number of planets with water and life, or no planets at all. There could be an endless number of stars and galaxies, or no stars and galaxies at all. It's even possible that humans never existed. Many members of the scientific community may not agree with these findings, and until we have solid evidence to prove this, the theory will remain a theory. However, with time, Professor Hawking's final theory will have substance and proof. In the coming future, there will be many discoveries coming our way because the James Webb Telescope is on the job. So, what do you think? Is there any truth to the multiverse theory? Do these theoretical implications mean that there are multiple unique versions of this universe? And what more will the James Webb discover in the coming future? Let us know in the comments below. And as always, thanks for watching Space Traveler.